everyone, welcome back to my channel. In today's video, we are gonna dive deep into the most popular and powerful clustering algorithm, DBSCAN, that stands for Density-Based Spatial Clustering of Application with Noise. If you have heard density-based core points or noise points and weren't sure, don't worry. By the end of this video, DBSCAN will feel easy and intuitive. Now let's dive right into it. So what is DBSCAN? DBSCAN is an unsupervised clustering algorithm that is grouping points together based on their densities. Unlike k-means, you don't need to specify the number of clusters here. The algorithm discovers cluster on its own, and it's great for data that has arbitrary shape, a lot of noise and outliers. K-means is an algorithm that is very sensitive to outliers and assumes that the clusters are to be in spherical shape. So this is an improvement on K-means. Certain key points that are specific to DBSCAN. First one is epsilon. Now epsilon is the radius around a given point. So for instance, if we have this as the point, draw a circle of radius epsilon around it. So whatever points that are lying inside this circle become neighbors. So this is a neighbor, this is a neighbor, this is a neighbor, this is a neighbor of this point. And we can think of it as how close points need to be considered as neighbors. Now second terminology is minimum points, which is the minimum number of points needed to form a dense region. Now there are types of points. First one is being core point, which has at least minimum neighbors within its epsilon radius. The second one is border point. This is not a core point, but is reachable from another core point and has to be at an epsilon distance from that core point. And a point that is neither a core point nor a border point is assumed to be a noise. Now let's see what is the algorithm exactly about. So first step would be to pick an unvisited point. Now we check how many points fall into its epsilon radius. If the number of neighbors is less than minimum points, we mark it as noise. If it's greater, we mark it as a core point and add it to a cluster. Further on, we start expanding its neighbors. We continue this until all the points have been visited. Now, let's walk through an example. Let's say the minimum number of points is 3 and epsilon is given as 0.5. Now we'll pick a node at random which is unvisited. Let's say we start from B. Gonna draw a circle of radius epsilon. Let's say that if A, C and D fall within this radius. So B's neighbors come out to be A, C and D. And including B, we have 4 neighbors, which is more than the minimum number of points. So then B qualifies as a core point. Let me make a cluster C1 and now I'm gonna add B to it. Now B is a core point. We have pushed it to cluster and marked it as visited. Now we are gonna iterate over its neighbors, which is ACD. Now let's say we first pick A. Now we are on A. Its neighbors I can see is B and C. Including A, it is more than equal to the core points. Now this qualifies that A itself is a core point. So we put that to our cluster and then we recursively move to its neighbors. Now when we move to B, we see that B is already visited. So we are now gonna move to C. We see has neighbors A, B and D, and including C itself, it has 4 neighbors, which is more than equal to 3. So C again is a core point. We put it to our cluster, mark it as visited, and then recursively iterate over its neighbors. So then we come to D. DVC has neighbors B, C, and D itself. It again is a core point. We put it within our cluster C1, then mark D as visited. Now everything here has been visited. Now we move to the next point. Let's say we pick F. Now currently we are on F. Its neighbors are E and G, and including F, it has 3 neighbors, which is more than equal to the minimum number of points. Now F again is a core point. So we have one more cluster. We're gonna put F within it. Now we mark F as visited. Now we are iterating over its neighbors. Now we go to E. E has neighbors F, G, and E itself, which is more than equal to the minimum number of points. So E is a core point. So we will put that to our cluster, then mark E as visited and recursively iterate over its neighbor. We go to F, see that F is already visited. Then what is remaining is G, which is a neighbor of E. Now we go to G, we see that G also is a core point, and we put G within our cluster C2 and mark G as visited, and there are no other unvisited points here. Next we come to this point H. We see that it is neither a core point nor a boundary point, and thereby we label this guy as a noise. Now this is a noise. Now there is an important thing that we should keep in mind is that we should never expand boundary points. Write it here as well. We should not expand boundary points. Let me take an example here. Let's say I have a point here, I have a point here, here, and here as well, and one here. And minimum points given to me is, let's say, 4. Now if I'm starting off from here, I see that it has 1, 2, 3, including itself 4 neighbors, so it is a core point. Now I will expand its neighbors. Let's say I expand this neighbor first. Now I'm here. Now I count the number of neighbors here. I see that it has only 2 neighbors. One is this, and the second one is this neighbor. Now so because this then becomes a boundary point, not gonna expand this further. I will add this to my cluster, but will not expand this further. So the chain from here to here will not propagate. Let's get started with the code walkthrough. So what we are doing first is that we are iterating over the points. We go to a particular point and we check if it is unvisited or not. If it is unvisited, we calculate its neighbors. And if the number of neighbors come out to be less than minimum number of points, we mark it as a noise. Else, we increment this cluster ID, mark the current point as core point, and then we expand that cluster. In the expand cluster logic, what we are doing, we are putting the current point in a particular cluster, then we are finding its neighbors. Post that, we would iterate over its neighbor. If that neighbor is not visited, we put it within our current cluster. Then we again find that neighbors to see if the neighbor is a core point or not. If the neighbor is a core point, we would recursively call this expand cluster logic. Else if the neighbor is not a core point, then it would mean that that neighbor is a boundary point, and then we would add it to that cluster, but we would not expand it further recursively. So as you can see here, we are using Euclidean distance to calculate the distance between the points. We can have any other distance metric as well. Thanks for sticking around till the end. I hope DBSCAN feels a lot less intimidating now. Don't forget to like, share, and subscribe if you enjoy clear and simple ML explanations. See you in the next video. Keep learning and keep exploring.